Meet the MM8108 EKH05 Evaluation Kit, your gateway to Wi-Fi Halo IoT development. Built around the Morse Micro MM8108 SoC, it's the perfect platform to explore long-range, low-power IoT connectivity across applications from smart homes to industrial automation. Now, what is it? The EKH05 is a fully integrated Wi-Fi Halo development board. It has, of course, a Morse Micro MM8108 globally certified Wi-Fi Halo module. It comes with an STM32 MCU. It has an STM Bluetooth module, and it has an integrated camera, ton of different sensors, and an onboard debugger. All the hardware you need in order to get developing fast. We support a range of different development platforms across Windows, Linux, and Mac, where you'll find a complete SDK and example codes so you can get programming quick. So whether you're prototyping a connected sensor or you're building a full IoT development structure, the EKH05 kit will help you move from concept to proof of concept fast. Let's unbox it, set it up, and I'll show you how to get started. So inside the box, you'll find everything you need to get started. So we open her up. We're presented with a quick start guide, which will walk you through the quick and easy setup. We get a USB-A to a USB micro cable and a Wi-Fi Halo SMA antenna. And then, of course, the MM8108 EKH05 board itself. Now let's take a look at what's on board the MM8108 EKH05. So starting at the top, we have, of course, a Morse Micro MM8108 Wi-Fi Halo SoC. This is inside our Morse Micro fully globally certified module. For the RF, you have two ports, either the SMA port or the U.FL. This is resistor selectable. Moving down, we have an ST Blue NRG Bluetooth module, perfect for commissioning or even having your own Matter solution. Moving over here on the host MCU, we have the STM U585 processor. It's ultra low power and it has enough grunt to do any IoT application that you need. We've also routed out down the bottom here as many of the IOs and the peripherals as possible from the STM32 itself. So if you need some GPIO, I2C or SPI, you can get those down here. We have a current 420 sensor input. We have some buttons here. And then moving up over here, we have some integrated sensor devices. So you have an accelerometer, a temperature sensor and humidity sensor. We also have an RGB LED. And then up here, we have two expansion ports. One is the microbus port, which is these headers here. And then secondly, we have a quick connect. So you can easily jump online, grab any sensor you need for these two peripherals interfaces, and you can get developing for your application. Moving over, we have a JPEG still image camera that is pre-populated on every single EKH05 out of the box. And then down the bottom here, what we've done is we've routed out every single power rail onto its own header pins so that you can measure in system how much current each rail is measuring. So you can hunt down that last 100 microamps. Moving up, we have a few different power input options. So we have a terminal block header, we have a JST battery connection port, we have the USB-C, this is power, but also the USB lines go directly to the STM32. And then lastly, we have a USB micro port to the ST-Link programmer and debugger. So it gives you all full debugging for the STM32. If you did want to change from USB power input into battery power, you just need to change this header here. So that's all the hardware you will need in order to get running quick, developing Wi-Fi Halo IoT solutions. So let's get started setting up our EKH05. So first of all, we get our Wi-Fi Halo SMA antenna. We connect that. And then we get our USB-A to USB micro cable that comes in the box and we plug that in. That goes to our PC. And out of the box, the EKH05, it's programmed with a simple demo application where the RGB LED, its color is based upon the position. So as I rotate, we can see it change color based off the accelerometer reading. Now, of course, we want to get started with Wi-Fi Halo as quickly as possible, but because the MM8108 EKH05, it's a truly global evaluation board, it ships as a single worldwide SKU. That means we need to program the board with firmware that's suitable for our region. So whether you're in Japan, the US, Europe, or in my case, Australia, You simply load on the firmware from your region, and then you can get your Wi-Fi Halo set up. Okay, so next we need to program our eCatcher 5 with the demo application that's suitable for our region. This can be downloaded from either the Morse Micro website or our GitHub repo as well. Once you have that file, you then simply go to your PC with a firmware downloading application. In my case, I'd recommend the STM32Cube programmer. So if we go up here to Erase and Programming, now if I press Connect up here, it will connect to my eCatcher 5 using the ST-Link onboard. Then I select the right file. So in my case, it's the eCatcher 5 demo over SPI. So by default, the board's configured for SPI. I've got version 174, and for me, the region is AU. I then select Verify Programming, Run After Programming, and Full Chip Erase, and then start programming. That takes a moment, and then once it's programmed, your eCatcher 5 is fully ready for the eCatcher 5 demo with Wi-Fi Halo capabilities. Now that we have the eCatcher 5 Wi-Fi Halo demo downloaded onto our eCatcher 5 itself, we then need to bring in an access point so we can communicate over a Wi-Fi Halo network from our station as eCatcher 5 to our access point. In my case, I'll be using the Morse Micro's Halo Link 1. I've got one pre-prepared over here. And the first step, I need to plug in, of course, power to our Halo Link 1. That's over USB-C. And then next, I need to plug in an Ethernet port. This will go and be connected to my PC. So now that we have the Halo Link 1 set up and ready to go, the next thing is to have a look at the logs from the eCatcher 5. We can do that directly using a terminal emulator on our PC. This is through the ST-Link as it provides us with a virtual COM port. So in my case, I'm using Teraterm, and if I connect Teraterm up at the right speed and the right port, I now press the STM reset button. And what we can see here is all the logs that the eCatcher 5 is putting out directly to our PC. So if we were to look at them, we'll see it's setting up different peripherals on board, and then it also sets up a Bluetooth GATT server, which we can connect to. But then the coolest thing about this demo is we see we've set up a connection to our Halo Link 1 over Halo Wi-Fi. And now what happens is the eCatcher 5, it will create its own web service. Now this web service, it will be sent to the Halo Link 1 over a Wi-Fi Halo network, which we can get access to through the connection on our PC to the Halo Link 1 itself. All we need to know there is this IP address. So if we go to our web browser and then we go to that IP, what we see here is the eCatcher 5 web service. Now, the web server itself, we give you as much information from all the peripherals we can. The first thing we've got here is the actual camera output from the JPEG camera unit. So we can see here, if I hover over, there I am. It does a refresh rate about every 4 seconds. We can also store an image from the camera module onto flash memory simply by pressing this button here. We get a flash of an LED. And then if I press here, we can see the image that's stored in flash is presented to us in the web service. We can also control onboard LEDs by pressing this button. The output from the accelerometer, that's also displayed in the web server. We have output from our temperature and humidity sensor. So if I put my finger over it, we'll see that the temperature goes up. We can also ping our Halo Link 1 directly from our eCatcher 5 over the Wi-Fi Halo network. We just need to type in the right IP address. And then if we start that and then scroll down to the bottom, we can see that pings are coming through. The web service itself, it gives you additionally a iPerf server. So when you're ready to start doing throughput testing, you can do that directly from this interface. The eCatcher 5 demo, it also is running a live Bluetooth GATT server. So you can get your iPhone, you can connect to your eCatcher 5 over Bluetooth, and it will be giving you information from the temperature sensor and also the accelerometer. So the next thing is, of course, to get your software development environment set up so you can start writing your own applications on the eCatcher 5. Our recommendation is to download our CMSys pack. This is hosted on our website and also our GitHub repo. And then you can install that pack directly into the STM32Cube environment. I've done that here by following our user guide. And then once you're set up, you'll be presented with the Cube environment like this. And then if we go to the .ioc section here, we of course get all the pinout, but what we want to see and have a look at is select components. And this will present to us all the different options available for our software environment. And then if we drop down this one here, what we find is all the software example applications that Morse Micro provides as a part of this pack. So we have some scan, we also have an AWS IoT example, an MQTT demo server. There's also a CLI interface. The demo we're currently running is the EKH05 demo here. Once you've selected your demo application, then you will have access to all the code that's written in order to have that demo working, and that can be found in the source files on the left-hand side here. And with that, you'll have everything you need to start developing quickly within the STM32Cube IDE environment. For applications, the EKH05 can be used for a range of different IoT innovations, including home security or smart locks, building access and automation systems, industrial sensors, performance monitors, smart city networks, you name it, the EKH05 will help you get there fast. And with Halo, you get range, reliability, and the efficiency needed for IoT applications. And that's the MM8108 EKH05 Evaluation Kit, a complete platform for exploring the full potential of Wi-Fi Halo. Check out the links in the description. We have our user guides, our app notes, check out our GitHub repository, and even go on our developer community. So you can start building, testing, and connecting with Morse Micro's Wi-Fi Halo.